Okay. So welcome everybody to our June 2023 virtual general meeting. I'd like to welcome our main speaker, Dr. David Grinspoon, aka Dr. Funkyspoon. He's going to be talking with us tonight about the decade of Venus, planning our return to Earth's mysterious twin. For many programs, as you can see, we have Dr. Barbara Harris doing the variable star of the month, as well as Frank Kane, our vice president, doing member astrophotos. So I wanted to give a little plug for CFIS membership. I didn't list it here, but if you go to our website, cfis.org, you can learn all about benefits of membership. Probably one of the coolest aspects of being a member is access to loaner scopes. And I'm going to list the email address for Chris Hunt, our member loaner scope chair, to learn more about the loaner scope program. So coming up, the sun is over the Astronomy on Tap logo there, but we have a couple events coming up. You see one event hosted by the Planetary Sciences group with some guys over at UCF. That's going to be on June 20th. We have our July virtual meeting coming up with Dr. Katie Mack. Thanks again, Frank, for arranging that. And then these classes are full, but it's important to know about them because if you are interested in these courses you see listed here, at the bottom, the CFIS Intro to Astronomy course for beginners and intermediate astronomers, the classes are full, but if we are getting a big interest in these classes, go ahead and email anybody on the board, mention to anybody that you meet at CFIS events. And if there is a big interest in these groups, we will try to schedule more to accommodate all the people that want to go through these courses. So again, right now, these courses are full. So if you have not already signed up, you're not able to join them. But again, we want to let all the members and the general public know about these courses so we can see if there's interest in scheduling more and maybe even an advanced course one day. So as promised, here is the email for Chris Hunt. He is the program chair for our Loaner Scope program. Thank you to Chris for all your hard work. Go ahead and email him if you have any questions about how to join the Loaner Scope program. It's a really good way for new members and people that have been a part of the club for a long time to try different types of telescopes in their own home, bring it out to star parties. It's really one of the best benefits of membership. And so with that, I want to hand it back over to our Vice President, Frank Kane, so he can introduce our main speaker. Thank you so much.
All righty, thank you. And some quick housekeeping. If you have any questions for our main speaker or anybody tonight, do use the Q&A button at the bottom of your screen there. I'll be keeping an eye on that and relaying any questions throughout the night. For anybody, anything's fair game. And before we dive in, a couple of quick announcements from myself here. Watch out for a member survey going out tomorrow. We want your thoughts of what you want to get out of the club and what your goals are. So the board will take a look at your responses and craft our budget accordingly. So please do take a few minutes to respond to that when you see it coming through. That'll be through our groups.io group. And welcome new members, by the way. I hear we had a pretty good outreach event at the Orlando Science Center last Saturday. So thanks to Douglas Woods for organizing that and everybody who participated. And if this is your first CFAS meeting, welcome to the club. And with that, allow me to introduce our speaker tonight, David Grinspoon. David Grinspoon is an astrobiologist, award-winning science communicator, and prize-winning author. He's senior scientist at the Planetary Science Institute, where his research focuses on climate evolution on Earth-like planets, potential conditions for life elsewhere in the universe, and the planetary scale impacts of human activities on Earth. He's involved with several interplanetary spacecraft missions, which we'll hear about a little bit tonight, I think. Currently on the science team for NASA's DAVINCI mission, which will launch to Venus in 2029. In 2013, he was appointed as the inaugural Chair of Astrobiology at the U.S. Library of Congress, where he studied the human impact on Earth systems and organized a public symposium on the longevity of human civilization. He's given dozens of public lectures about climate change in the solar system. His technical papers have been published in Nature, Science, and numerous other journals, and he's given invited keynote talks at conferences around the world. Grinspoon's popular writing has appeared in Slate, Scientific American, Natural History, The Washington Post, The Boston Globe, The Los Angeles Times, The New York Times, and I'm sure you've all read him in Sky and Telescope, where he's the contributing editor and writes the regular Cosmic Relief column. His newest book is Chasing New Horizons, Inside the Epic First Mission to Pluto, co-authored with Alan Stern. I got mine, you got yours? All right. And his book, it's got some other books too, Inside the Epic First Mission to Pluto, co-authored with, we just talked about that, sorry. His book, Earth in Human Hands, was named a Best Science Book of 2016 by NPR's Science Friday, and was a finalist for the AAAS Subaru SB&F Prize for Excellence in Science Books. His previous book, Lonely Planets, The Natural Philosophy of Alien Life, won the Penn Center USA Literary Award for Nonfiction. He lectures widely and appears frequently as a science communicator on television, radio, and podcasts, including as a frequent guest and host of StarTalk Radio, which is actually where I saw you the first time, way back in when it was on Nat Geo. Also a musician, he leads the House Band of the Universe. I'd love to see that sometime. And Grinspoon was awarded the Carl Sagan Medal for Public Communications of Planetary Science by the American Astronomical Society. In 2022, he was elected as a lifetime fellow of the American Association of the Advancement of Science. And last but not least, Asteroid 22410 Grinspoon, a main belt asteroid, is named after him. Dr. Grinspoon, I think that is the most epic bio I've ever read in my life. That is awesome. I'll hand it over to you. Welcome, Dr. Grinspoon.
Oh, thank you very much. I really appreciate the invitation and the opportunity to spend a little time with you all this evening talking about my second favorite planet in the entire universe, the planet Venus. I only say that because I'm loyal to Earth, but as far as planets that we study elsewhere, I've had a long time love affair with Venus. And by the way, I also I have a particular set of associations with the state of Florida. Just about every time I've been there, it's been an incredibly excruciating but then thrilling experience, because almost every time I've been to Florida has been for a rocket launch, carrying a spacecraft that I care sort of too much about. So that's why it's nerve-wracking. But it always ends up being memorable and thrilling. And I was there for several Mars launches and for the New Horizons launch, and I'm hoping to get down in October for the Psyche launch. So anyways, that's my association with your state primarily, and it's a good one. And I have a talk kind of. Whoops, let me share my screen here. Share screen. There it is. Did I do that right?
There we go.
There we go. Now, if I've done this right, which screen are you guys seeing? My actual presentation or my sheet?
Yeah, you got the right one. We got the actual
Okay, cool. Because I find that with Zoom 50/50, it does the wrong one. I have to do the switcheroo. So this is excellent. And just so you know, these are slides that that I had kind of assembled for a talk I gave a few weeks ago at a planetarium in Berlin, actually, on the same topic. But I feel like I have a few too many slides queued up, because I want to get through in enough time so we have some time for discussion and Q&A. But I also realize that since I'm speaking with an astronomy society, that I figure from my experience with similar groups that a lot of you are pretty serious about it and know a lot. So I'm going to go quickly through some background stuff that you probably already know. So fasten your seatbelts. I have to start off with at least mentioning the great beauty of Venus in our evening sky, which is really on display now. As I'm sure you've noticed, we're pretty much at greatest elongation, or within a week or so of it. And it's just incredibly brilliant in the night sky. And of course, Venus as an object in the morning and the evening sky is how it first came to human attention. And given its incredible brightness, the second brightest object in the night sky other than a full moon, and its sort of enigmatic movements of appearing for a few months and at dusk and disappearing and reappearing for a few months at dawn. It's been a very noticeable presence in the sky long before we were a scientific species, and so Venus is the subject of all kinds of origin stories and mythologies, and of course in Western culture we associate her with the goddess of love and beauty and female goddess, and this is of course Botticelli's Venus representing that. But it's interesting to note that a lot of other cultures were very, very aware of Venus, and in fact probably the most astute pre-scientific Venus observers at all were the Mesoamericans, the Mayans, the Toltecs, the Aztecs, and for them mostly Venus was in fact a dude, a macho kind of conquering warrior figure, and these, for instance, are the 5 Mayan figures of Quetzalcoatl, their Venus deity, going down into the underworld 5 times to do battle with the enemies of humankind, war, pestilence, all the bad stuff Venus was vanquishing to make the world safe for humanity. And when I gave this to a public audience recently, I said, now can any of you guess why there are 5 Venus figures? And I bet some people in this audience know, but of course, because the Mayans and the Aztecs knew a lot about the motions of Venus. They had figured out a lot of how to predict it and subtle aspects of the appearance cycles. And then, of course, the scientific revolution really got started, in a sense, with Galileo's observations of Venus and showing its great the great utility of those observations for the Copernican revolution, which again is something I don't even have to tell this audience what that is, and probably don't have to talk too much about the role of Venus in the Copernican revolution, because you know all this, how the changing size and aspect, the apparent size and phase of Venus seen through the telescope, the cycles of that make it very evident that both Venus and Earth must be orbiting the sun, or else it just doesn't make sense what Galileo's reporting there. So we meaning the inheritors of the scientific revolution, became aware really of what Venus was and what Earth was through those kinds of observations. And of course, now fast forward to where pretty much we are in the orrery today, or this was actually a couple of weeks ago, but you can we now have this picture of where Earth and Venus are in their orbit, and why Venus is at greatest elongation just about now, or just about a few days ago. Somebody at made me this really nice animation, and one thing you notice, see the shape that Venus is tracing out in the sky there. Now you can see it in the evening sky. See that? If you treat it like an Etch-a-Sketch and let it carve out a shape over the over the many months of its evening apparition. The interesting thing is those shapes were well known to the Aztecs and the Mayans. A lot of modern astronomers seem to not be as aware of them. But the interesting thing, of course, is that because Venus passes us on the inside lane 5 times every 8 years, that those shapes repeat, and they're different from evening appearance to evening appearance until you go through 5. And then the 6th one is an exact repeat, or just about exact repeat, of that first one. And so every 8 years, we cycle through one of those 5 shapes. And this is why the Mayans and the Aztecs had 5 Venus god glyphs, because they knew all about this stuff. And by the way, another implication of this that's kind of fun for us for we close observers of the sky, is that wherever Venus is tonight, both when it's rising and where it is in the sky, is pretty much exactly where and when it will be 8 years from now on the same calendar date. So I bet some of you do this as well, enjoy things like that. So I'll notice where Venus is on a particularly important date, and then I'll mark to myself, oh, it's the Venus anniversary of that 8 years later. And it just so happens that I'm aware of this right now with Venus's incredible evening apparition we're having. I'm pointing to west for me over here. And this next week will be my my 8th wedding anniversary on the solstice. And the night of our wedding, Venus and the moon and Jupiter were doing this awesome thing, as they often do in the western sky. And I'm very conscious of the fact that that our 8-year Venus anniversary is coming up, and so Venus will be in the same place that I remember it being on that important to me evening 8 years ago. So, anyways, that's the fun thing, the kind of fun thing that observers of Venus can do in the sky, and that the Mesoamericans were really into. Now, moving forward, right up until the beginning of the space age, it was widely believed, not just by science fiction writers, but by scientists, that Venus is probably pretty Earth-like, and maybe just sort of a tropical version of Earth, because it's a little closer to the sun, has clouds. Clouds are probably made out of water. There was this very common idea that Venus might be sort of a swampy Earth planet. And of course, there's a lot of great science fiction from that era, with the action taking place on an oceanic Venus. A Lucky Star in the Oceans of Venus was a favorite of mine as a kid, where Lucky does battle against in the deep oceans of Venus, where there are domed cities, and Lucky has to go out and do battle against the giant killer jellyfish and the telepathic frogs, and saves the day. Anyway, so that Venus is kind of burned into our brains of pop culture. And then, of course, there are a lot of goofy movies, Zsa Zsa Gabor and Queen of Outer Space, and that Venus was also it was just very much a part of pop culture and scientific culture. And that bubble was kind of burst abruptly in the first interplanetary act of the space age was Mariner 2 in 1962, and was the first successful spacecraft to reach another planet. Nobody ever talks about Mariner 1. Those days, we did 2 of everything. Nobody ever talks about Mariner 3, but Mariner 4 made it to Mars. That was how we guarded against the fact that we really didn't know what we were doing at the beginning of planetary exploration by making 2 of everything. Now we're more frugal with our budgets, but we're also better at we have a higher success rate. So, anyways, Mariner 2 made it to Venus. Very simple spacecraft, had basically one instrument, a microwave radiometer. You can see that sort of antenna-shaped thing in the middle there. And it made a crucial observation, which was that the anomalous microwave radiation, which had been observed at Venus previously and had different origin ideas being touted in the literature. But one of those ideas was that Venus was really hot on the surface, and that was producing this basically thermal radiation, but it was a minority view. But Mariner 2 proved that was true. Its microwave radiometer showed that that excess radiation was coming from a very, very hot surface, not from the upper atmosphere, ionosphere, as some had thought. So that showed that was the first scientific result ever from a spacecraft at another planet, was the microwave radiometer experiment with Mariner 2. And that first result showed us convincingly that tropical wet Venus of our science fiction stories did not exist. That ocean evaporated in an instant, and what we had instead was a planet with surface conditions far too hot for liquid water or for stable organic matter. So this was greeted with some level of disappointment, and the New York Times editorial after these results were reported was entitled "Venus Says No." Was seen as sort of the downfall of this romantic idea of an Earth-like Venus. And you can see that the part I've highlighted here in the lower right, they said the message from Venus may mark the beginning of the end of mankind's grand romantic dreams. So that what a bummer. We should have missed and never explored the planets if we were gonna have our dreams crushed. But it gets better, because we ended up finding that Venus is actually a pretty interesting, and I think actually a really beautiful place, just in ways that we weren't expecting. And this began the era of course, comparative planetology, where we have this powerful ability to learn about Earth and the other planets, not just by considering them as individuals, but by the comparative study that reveals so much about sort of the general workings of planets and the different life histories they can take on. And then, of course, more recently, we have the exoplanet revolution, where now we see our planets embedded in a universe full of planets, something we long suspected but have more recently confirmed is the case. And so then we have the sort of synergism between the small handful of planets that we can get to with spacecraft, Venus, Mars, and further out in the solar system. We can learn a lot potentially about a small number of planets that are all kind of random examples of planetary evolution. So how can we generalize to planets in general? Well, then we have the exoplanets, where we have a vast number, so much better demographics and much better representation of the different outcomes that planetary formation and evolution can take, but it's much, much harder to get any information about them. So we have this growing number of planets that we can get little tidbits of information about, and then we have this small number that we can get to and really tease out how they're working. And I say those two efforts are synergistic, because the exoplanets give us the context to know where the planets here fit in, and the planets here in our home system give us the detailed knowledge that then we can apply to have some hope of understanding what's really going on in the exoplanets. Anyways, so we're going to zoom in now on this comparison, which is so compelling because Venus really is Earth's twin in these fundamental ways in terms of bulk properties, size, density, escape velocity, and presumably initial composition, although we still have some big questions about that. And then they've evolved to such drastically different environmental states with, the top two lines here remind us of the similarities in diameter and mass, and therefore density, escape velocity, and all that. And then down below that, the drastic differences where Venus is almost all CO2 in its atmosphere with a few percent of nitrogen and traces of other things. And Earth, of course, very different, where CO2 is an essential trace gas for life, but a somewhat bothersome, troubling outcome of industrial activity, because you don't want, we need the greenhouse, you don't want too much of a good thing. I'll get back to that in a second. And then, of course, the drastic differences in surface pressure, temperature, and the water abundance is such a striking difference, where Earth is a water planet. That determines so much about our planet, and yet Venus is 100,000 times drier than Earth, and so similar in so many respects, and so starkly evolved such starkly different states. So just a little about the history of exploration. Of course, it's been very hard to learn anything in detail about the surface environment, because Venus is completely covered in clouds, which means you can't see it from orbit or from a telescope. And below those clouds is that incredibly hot, dense atmosphere. And the clouds, of course, themselves are made out of corrosive concentrated sulfuric acid. So So it's a challenging place to explore from anywhere but orbit, and from orbit you have to get pretty clever to learn anything about the surface. But of course, the Soviet Union had great success in landing several spacecraft to the surface of Venus. They're still the only country that's ever done that, or anything that's survived for an hour at the surface of Venus. And they did it with these huge sort of these landers that look like diving bells, and that's essentially what they are, just these very thick, pressurized, insulated capsules, containers surrounded by phase change materials to kind of keep it refrigerated as long as possible, and then with these landing rings and shock absorbers. And they just sent this design over and over again and improved it, and eventually had success. And then so we have a handful of images of the surface of Venus, and you can see that it's these sort of you have this appearance at all these landing sites of these kind of platy rocks with a lot of fine material, and this is consistent with the idea that these are generally eroded volcanic landscapes. So what they look like, and it's consistent with what we see from orbit. Well, this is an artist's conception of what one of these Veneras might look like today, the sort of corroded, rusted hulk of one of those spacecraft. And in a nutshell, we have this idea that Venus got to be the way it is today because of what we call the runaway greenhouse. And the sort of cartoon version of this is that since water itself is a greenhouse gas, if you start off a planet a little bit hotter, otherwise similar to Earth, you'll have more evaporation of water from the heat. The greenhouse is enhanced by the water vapor, which makes the surface hotter, and that causes more water evaporation. And that it's a powerful positive feedback with nothing to get in the way, or not much to get in the way. And the result is that we believe the ocean's essentially boiled off. And when you have the ocean, all this vapor in the atmosphere, it's much more vulnerable to being, water molecules are more vulnerable to being split up by ultraviolet radiation, especially from the young sun, very ultraviolet active. And then the hydrogens just escape off into space, and the oxygen, some of them escape and some of them react with mantle surface material. Anyways, once your water evaporates, it's easy to lose it. And so we think that some version of that is what happened to Venus. And so the result today is Venus is really hot and really dry. We learned a little bit more, actually a lot more, about the surface of Venus when we realized we could image it with radar. You can see through the clouds, essentially using radar, kind of like flash photography in the dark, because radio waves aren't unimpeded by clouds, and so you can bounce the signal off the surface and then retrieve that signal and synthesize images as you orbit. Here's this is actually Magellan in 1989 being launched from the cargo bay of the space shuttle. And you can see at the bottom there, the big rocket stage is going to send it towards Venus from Earth orbit. You can see the folded up solar panels, and at the top you can see the big antenna, which was not just the communication link with Earth, but it was also the main scientific, really the only scientific instrument on Magellan was this big radar instrument. So the antenna was used for both. It would just turn away from Venus towards Earth when it was time to send the stuff home, and then turn back to Venus and orbit some more. And of course, with Magellan, we learned much of what still forms our basis today of knowledge of Venus geology, although we're still chipping away at it and getting psyched to send some new missions. But you can see a planet that's largely composed of very smooth volcanic plains. These, we believe, are flood basalts, kind of like in the Pacific Northwest, the Columbia River Basin, or other famous big flood basalt areas of Earth, the Deccan traps of India, or the Siberian traps of northern Russia, and this dominates the planet. And then you can see these, especially equatorial right there, these smaller regions of very elevated rough material. We call it tessera, which is a word that means tiled, and that's just those are the really old terrains that seem to predate all this volcanism, and they're very highly disrupted, tectonized, rough mountains. Here's a close-up of one of the tessera areas, and we're actually going to one of these areas with our DAVINCI mission in a few years. Something I'm very excited about. I'll get to that in a few minutes. But the other aspect of Venus is not just the flood basalt volcanoes, but Venus is also a wonderland of different styles of volcanism, it turns out. Here's a shield volcano, sort of Hawaiian style shield volcano, and you can see some of these flows running for hundreds of miles out onto the plains. The rougher areas tend to be brighter in these radar images, so the younger flows are the brighter ones, or the rougher flows, so superimposed on older ones. This is another kind of volcano nicknamed pancake domes for obvious reasons. These are about 10 kilometers across, a couple thousand meters high. So if you were in really good shape, you could hike one of these in a day. If you had a really good space suit with very good thermal control. Otherwise, you'd be dead. But anyways, just some other beautiful volcanic features on Venus. There's a lot of these, but I'm going to go through this kind of quickly. But just some amazing flows and a tectonic ridge here with the flows kind of bursting through the low point, and these sort of lobate flows coming out of a fissure in the ground. Venus is just a wonderland of volcanoes, and colleagues of ours mapped recently all the volcanoes on Venus in the Magellan data, and it's an astounding number. Many tens of thousands of volcanoes mapped on Venus. I think it's like 80,000 or something ridiculous like that. And of course, we don't. These are just the ones we can see in the Magellan resolution data. We'll discover more when we get better data. There are also impact craters on Venus, and the impact craters tell kind of an interesting story because there are not that many impact craters compared to, say, Mars, which is peppered with them, telling us that geologically Venus is actually kind of young. If you map all the craters on Venus, there's about 800 some craters, which for a planet its size is not very many, and it tells us that the average surface age is less than 1 billion years, which for a terrestrial planet is actually young. If you think of the other terrestrial planets, you look at the top here at the Moon and Mercury and Mars, and on the bottom there's a time scale, and this is just a sort of a schematic graph reminding us that most of the surface area of Mars and the Moon is ancient. In other words, if you pick up a random rock at a random place on Mars, it's typically going to be many, many billions of years old. And on the Moon, if you found a rock that was younger than 3 billion years, that would be really strange. These are planets that had most of their geological activity early on, and then it's been very quiescent since then. Earth, on the other hand, at the bottom right here, is very different. It's a geologically alive planet. So you can see that the schematic here, meaning that almost all the surface area of Earth is, just a few 100 million years, let alone less than 1 billion years old. If you go to some random place on Earth and you pick up a rock and it's more than 1 billion years old, take it to a museum. That's a very rare and unusual thing on Earth. There's almost none. And the point of this really is to show you that Venus is in the category of Earth in that sense, that its surface seems to be young. The craters are telling us that. Now you see all the question marks because there's a lot of controversy about really what the history is of geological activity on Venus. So we know it's young geologically, but how active is it today is still one of our big questions. And it's an interesting question because we're trying to find out the sort of systemic behavior of Venus, and do Venus system science in the way you've heard of Earth system science. We're trying to the atmosphere is complex. The surface, we believe, is active. There's a lot of circumstantial evidence for active volcanism on Venus. I'll show you a bit more of it in a couple of minutes. But my favorite bit of evidence for why there are active volcanoes on Venus, I like to say, you can see with your naked eye, if you go out this evening, evidence for active volcanoes on the surface of Venus. And in fact, since we're all on the East Coast here, I will say, look out there in a couple of hours in the West. The fact that Venus is shrouded with these bright sulfuric acid clouds, it turns out that the clouds probably would go away in something like a few million years, probably less than 10 million years, without an active source of sulfur. So we think that sulfur dioxide is feeding those clouds from a volcanic source over time. So there's still a lot we have to figure out, but I think there's chemical evidence in the atmosphere that there has to be active volcanism, and we keep seeing kind of circumstantial geological evidence suggesting that there is, although one of our big motivations for going back there with some of our upcoming missions is to really nail down that question and find, what we call the smoking gun of the volcanic activity on Venus. So I'm not going to go through all the missions since those early days, but after Magellan, there have been a couple of important ones. There was the Venus Express, was a spacecraft sent by the European Space Agency in the early 2000s, and a sort of small but mighty spacecraft with this really good infrared multispectral camera that was the first spacecraft that really sort of revealed some of the interesting atmospheric dynamics happening below the clouds, because with these, if you look at the right infrared wavelengths, you can actually see motions in the middle cloud. In fact, this is some Venus Express data showing the kind of thing that we found. And another great thing that Venus Express did, which was also kind of surprising, was even though it was an orbiter and wasn't really designed to study the surface, we found that there are a couple of wavelengths. In particular, there's a little spectral, what we call a spectral window, just around 1 micron, so near infrared, where it turns out you can see the surface in this narrow spectral window. There isn't enough absorption in the CO2 and water and clouds to stop all the light from this 1 micron window. And so we were actually able to observe emissivity variations on the surface, which were interpreted. And this is a paper by Sue Smirkar and colleagues using this Virtus emissivity data from Venus Express to show what they believed was evidence of active volcanism on Venus. Basically, the idea is that these emissivity variations can only be explained if there are compositional differences, changes in the mineral composition of the volcanic rocks, that where the younger volcanoes have different chemistry than the older flows, presumably because they're young and they haven't yet had time to chemically equilibrate with the sulfur and other gases in the atmosphere. So this is seems to be evidence that there's something chemically different about the younger volcanoes, consistent with them having recent activity, and geologically recent means current, really, if you know what I mean. So that was exciting. And then much more recently, actually, just a little over a month ago in Science Magazine, some colleagues published a reanalysis of some Magellan data, where it looks as though they were looking at features that were imaged early in Magellan's mission, and then a few years later in Magellan was mapping Venus for about 4 years. And it passed over the same spot. There's some areas where it passed over a couple of years later. And they did a really careful analysis, and they seem to have found a volcanic vent that pretty convincingly and pretty dramatically changed shape over those couple of years. So this is more circumstantial evidence, but pretty compelling evidence that there is active volcanism on Venus. Now we want to nail that down and see if it's really true, but also importantly, see what the rate of volcanism is and the style and how it compares to Earth. Just a quick mention of Akatsuki, the first Japanese mission to Venus, which that's kind of a long, crazy story. I won't try to tell the whole thing now, but it made it to Venus, and it failed to go into orbit, and all hope was lost. But it wasn't, because it was able 5 years later to swing back by Venus, and even though its main engine had blown up, used the maneuvering thrusters to somehow get into orbit. Audacious, crazy scheme, but the Japanese Space Agency pulled it off, and Akatsuki's still in orbit. And it's done some great things. Several of its sensors have failed, but it's still operating. One of the most interesting discoveries from Akatsuki was this sort of, giant feature in the clouds, which appears to be a giant gravity wave being launched off the surface from Aphrodite Terra, from one of the big continent-like high-rise areas on the surface. So we've discovered these really interesting dynamical connections between the topography on the surface and what's happening in the clouds 40 kilometers up. So that, that's a huge gravity wave. Anyway, so we're learning a lot from these orbiters about a little bit about the surface and a lot about the very complex and interesting dynamics of the atmosphere. Speaking of atmospheric dynamics, a project that I've been a little bit involved in recently that produced some really cool and surprising results. We were trying to understand the climate evolution of Venus, and this question I alluded to earlier of the runaway greenhouse. Did it really happen, and when would it have happened, in terms of when in the sun's evolution would it have gotten warm enough to trigger the runaway greenhouse on Venus? Were the oceans of Venus just a brief phase very early in the planet, or could they have persisted through some significant portion of Venus's history? Previous climate models have not been up to the task of answering this question, but a group that I'm a little bit associated with decided that our GCMs, the general circulation models, what we use to model climate change on Earth, and I'm sure you know about GCMs. There's a schematic of one here. You've split up the entire atmosphere into lots of little boxes, and you pass variables between them, and you put all the laws of physics that you know that are relevant in there about radiation and atmospheric motion and cloud condensation and everything you can think of that you can code into that, and you run it. You watch how climate changes on a planet, and then at least with Earth you can compare it to historical records and all kinds of things and make sure it's working. Well, this hadn't been done for Venus, and there are reasons why it was sort of more difficult than you might expect to adapt these models to Venus. But finally, we have the capability to do this pretty well. And simulating the runaway greenhouse on Venus with a 3D model with clouds and everything, you find a kind of surprising result, which is that because Venus is a slow rotator, the dynamics do something really interesting to the clouds. The clouds organize themselves in such a way that the day side of Venus gets permanently cloudy, and the night side of Venus stays permanently clear. And that has the effect of maximum cooling of the planet, because the day side clouds act as a reflector. Just same reason you can see Venus so bright in our skies now. Clouds are really bright and reflective. But the clear night sky means that Venus can effectively and efficiently radiate its heat to space at night, just like on a cold winter night here on Earth. It gets colder if it's clear, and actually on cloudy nights it stays warmer because the clouds block the infrared radiation from cooling to space. So this is an ideal setup to keep the planet cool. And if the result is true, and we think it is, then it produces some really interesting changes in our view of Venus history. And this led to a paper we published called Was Venus the First Habitable World of Our Solar System? Because the surprising result, and I've got it highlighted here in the abstract, Venus climate could have remained habitable until 700 million years ago. In other words, through most of its history, Venus could have had oceans. If our result is correct, and we want to go to Venus and find out, but just quickly, the implications are startling, because if that's true, think of everything that was happening on Earth during all those billions of years when Venus might have been the ocean planet next door. You had the origin of life, and then photosynthesis and more advanced life of various kinds. And to think of these two ocean planets next door during all this time, it's very enticing, because it raises the possibility that Venus could have had a long and interesting biological evolution during that long period. Again, these are model results, and we don't have good enough data to say for sure whether they're whether they are representing the actual history of the planet. But we've got plans to change that. And now I want to just quickly talk about the decade of Venus. I'm part of a community that's been proposing Venus missions for a long time, and we've been also RANs for a long time. And NASA has, selected us for further study, but then not selected our mission. This has been happening for literally decades, and so our community has gotten kind of fatalistic about that. But then our luck really changed a couple of years ago. We have 3 new Venus missions on the way. In June 2nd, 2021 was the day that we learned that 2 of our missions had been selected. I'm on the DAVINCI team, and this was it's kind of life-changing and career-changing for those of us on the team when your mission gets selected. And then hopefully if it works, it'll be science-changing for everybody, because we'll answer some of these questions that we have. Veritas, DAVINCI, our mission's an entry probe. I'll tell you more about that in a second. Veritas is an orbiter. Veritas is having some difficulties, not of their own making, having to do with decisions made at NASA headquarters and budgets. But anyways, the launch is sort of on hold now, but the team is still hoping for a 2029 launch. It may be delayed more than that. And then the very next week, the European Space Agency announced that they had selected their Envision mission, which is an orbiter that'll go to Venus in 2031. So our community in June of 2021 went from having no future missions to having 3. And now there's actually a couple more that from elsewhere that may also be coming online. So things are looking a little bit up in the Venus exploration community. So let me say some quick words about Envision, Veritas, and DAVINCI. Envision is the European Space Agency mission. It's an orbiter. It's primarily a radar orbiter, but it's going to do much more than we were able to do with Magellan. I won't go through all the instruments now in detail, but the big, what's called VENSAR, the Venus Side-Looking Airborne Radar, is actually a U.S. contribution. So this is a European mission with a big U.S. contribution, the main radar instrument. But as you can see, there are instrumental contributions from several different European countries. The VENSPEC suite is basically designed to look at, everywhere from the upper atmosphere to, again, the surface and the infrared with different spectral ranges. And now that we know we can learn interesting things about the surface with the infrared, the idea is to go back with an instrument that's really optimized to do that. So, and this is a fun little animation showing Envision unfolding its solar panels, unfolding its radar instrument. And and I should have mentioned also that one of those instruments is optimized to do subsurface observations on Venus. So Envision will not only image the surface, but will be able to has radar wavelengths optimized to do subsurface, to look at subsurface structures, which will be really great. I'm going to skip forward a little bit. Veritas, also a radar mission, but with a sort of optimized differently. This VISAR, the Venus Interferometric Synthetic Aperture Radar, among other things, it can do interferometry, which is looking for really tiny but significant motions in the ground. So not just mapping the structure, but actually looking for real-time motions. So and between that and the Venus emissivity mapper, Veritas is really optimized to find the current activity on Venus. So we should really be able to nail this question of how active the surface is. Now, skip that. But DAVINCI is the mission that I'm actually been pretty involved in proposing, and I'm on the science team. And that's as I said, it's a entry probe, a titanium sphere about 1 meter in diameter that comes in on a parachute, and then the parachute drops off, and we open up ports. I should have said that we also do 2 flybys of Venus. We don't go into orbit, but we have 2 flybys with a carrier spacecraft that can do some cool ultraviolet observations of the clouds and such. But then our entry probe, we have instruments optimized to really answer some of these remaining questions about the history of the atmosphere, because we'll really nail down the isotopic composition of the gases, which we still really don't know, the detailed ratios of the different isotopes, which carry so much information about history of a planet. And we have this instrument called a tunable laser spectrometer I thought I had schematic of that, but we have a tunable laser spectrometer that is designed to detect just very, very minute quantities of certain gases. So we have that sort of tuned to certain wavelengths for some of the things we're really interested in, like sulfur gases, to really, really nail down the abundances. So we're very hopeful that these missions will clear up some of our big uncertainty that we have about the history of that planet. And then finally, the coolest thing that DAVINCI, well, I don't know about the coolest, but the most visually dramatic thing. So I think the coolest to the general public, and it is pretty cool, that DAVINCI will do is the first ever descent photography of the mountains of Venus. And we're going to land on Alpha Regio, which is one of these those tessera areas, very rugged, mountainous tessera, we think ancient tessera areas of Venus. And we'll get amazing stereo multispectral descent photography on the way down. And I shouldn't say we're going to land, we're going to reach the surface. And it's considered a success if we reach the surface and send everything back. There's a possibility of operating on the surface, but we'll see. We're not promising that. We're considering a full success if we reach the surface and send everything back. And just some of the questions we want to address. Did Venus ever have oceans? And was it habitable over time? Can we confirm this enticing idea we have of a possible habitable planet next door? How active is Venus today? And then larger but important question, how rare are Earth-like planets with plate tectonics? What can Venus tell us about, how to characterize our Earth in the wide suite of Earth-like planets? And our rocky exoplanets like Venus, what can we learn about this planet that will help us interpret what we're starting to learn about exoplanets in the Venus zone? Because really, in this sense, Venus is the exoplanet next door. And with that, I'll stop. I know I went a little longer than I said I would. I'd be happy to stay a little bit extra time too, if that will help, if you guys want to have discussion and questions.
Thanks so much, Dr. Grinspoon. That was awesome. I had no idea that Venus was potentially habitable for such a long period of time. Let me turn off your sharing here. We have a few questions here. So Isabel has a question about gravity waves in the context of atmospheric science. We hear about them a lot in, colliding black holes and whatnot. But going back to that discussion about the Japanese mission that found that gravity wave in the clouds, can you just explain what a gravity wave is in that context?
Yeah, so gravity wave is not a gravitational wave. It's unfortunate that they have similar names. Gravitational waves are, perturbations in space-time from colliding black holes that we discover with the LIGO instrument. They're really cool. This has nothing to do with that. A gravity wave is a wave in the atmosphere where the restoring force of that wave is gravity. So you see them a lot. When you see there's certain kinds of cloud features on Earth where you see these kind of large-scale undulating patterns. They make for really nice sunsets and so forth. Oftentimes you're seeing the effects of gravity waves. They are motions of the atmosphere that would be hidden, except they tend to cause rhythmic patterns and condensation and so forth. And they are any wave where the force sort of pulling, when you have a wave, it's because something is oscillating, but something's pulling it back. And in a gravity wave, the force that's pulling it back and causing that wave activity is gravity. That's what I mean by that.
Thanks. A couple of questions here from Luke Corwin. First of all, how long is the DAVINCI entry probe expected to survive once it enters the atmosphere? Will it have a parachute? I think you said it did. But...
It will have a parachute. The parachute drops off early. And one funny thing about probe science on Venus that's a little bit counterintuitive and then makes a lot of sense when you start thinking about it is sometimes people are like, well, why do you want to drop off the parachute? Don't you want to go down slowly and have the mission last longer? But you're playing a few different factors off each other because you don't want to last too long because the thermal constraints are really intense. So unless you're designing for that lower atmosphere thermal environment, you actually want to have your mission not be so long that you heat up. But the other thing is that the atmosphere of Venus is so thick that, especially the lower atmosphere, it's more like falling through water on Earth than falling through air because of the density. So the atmosphere really slows you down. And so like those Russian landers did not need parachutes to get to the surface. They just, the atmosphere slowed them down, and then they didn't have any rockets. They just had those shock absorbers, and that was enough. Our mission in the atmosphere lasts about an hour. And I know it seems crazy to be preparing for decades and spending, $700 million for an hour's worth of science. But we think it's going to be really good data, and we think it's going to be worth it.
Very cool. Luke also asked, what would constitute non-circumstantial direct evidence of current active volcanoes on Venus?
Yeah, so seeing things move, and I know I showed you that one vent so you could say, well, there it is. But with radar data taken years later, there's some level of doubt just because when you image radar from different angles, it can introduce artifacts. And yeah, I mean, I think that's a pretty good example. Or that could be a collapse feature. What if it's not a flow? But if we, with one of these orbiters, if we see multiple places where we see the ground moving and vents opening up and flows moving, and possibly with the infrared surface observations, we may see the direct heat signature. If there's a big enough, hot enough lava flow, we'll actually see the infrared signature of that from orbit. Finally, we might see a volcanic plume, the gases. If you see a plume of gas composition coming out of a volcano that's clearly chemically different from the surrounding gases, and you'll be able to tell that with, infrared observations. Those are the kinds of things that we'd say, okay, that's we got a live one here.
Excellent. One from Douglas Woods here. Are any of the new probes going to be able to detect lightning in the atmosphere? What could the level of electrical activity tell us about the geology and climate?
Yeah, the history of lightning is funny because it's been reported several times to be detected in terms of the electrical signal, like the static, like, you're driving on your radio. Well, people don't do this anymore, but you remember their cars used to have things called radios, like in the AM dial, and you'd be listening and driving near a storm, and we go like that radio static. We picked up the electromagnetic signal of lightning, and there've been some reports of detecting it optically, but you would think with the level that we think there is based on the electrical activity that we would have had more optical detections. So we believe there is lightning on Venus, but it's a little puzzling why it's been so hard to get optical observations of it. And, it's interesting because Akatsuki, which is there now, the Japanese mission, actually has had a lightning detector, and they haven't found it, and so it's a little bit of a puzzle. None of the upcoming missions are actually have instruments specifically designed to detect lightning, but I think probably the orbiters would be able to detect it in various ways. So it's still something we're trying to puzzle out.
Well, There's definitely lightning in Central Florida. We're getting some right now, so I can vouch for that. I'm going to sneak in one of my own questions here. So a year or two ago, there was a bunch of buzz in the press about potential biosignatures in the clouds of Venus. Whatever happened with that? Did that turn out to be a measurement error, or is the jury still out on that?
I'm glad you asked. So first of all, the idea of life in the clouds of Venus is one that has been around for a while, and I confess to have been that I've been a proponent, and it has nothing to do with these recent observations, just that general observation that the clouds, unlike the surface, are moderate temperature and pressure, and there is a lot of interesting chemical possibility there in terms of possible nutrients and possible energy sources. You're up against the fact that it's strong sulfuric acid, and it's interesting to, people have been pondering this question of, is there some alternative chemical system that could thrive in that environment? Now, enter this observation you're mentioning, the phosphine that was observed reported a few years ago. pH3, simple molecule that on Earth is associated with life and not with any other kind of activity. And phosphine, well before this discovery, had been on a short list of potential biosignatures on other planets. That if you saw it, it wouldn't prove life, but you should at least look more carefully at what's making it and consider that as one hypothesis. Anyway, so there was a report that came out a few years ago saying, aha, we found phosphine on Venus. And it raised quite a fuss, but quite a stink would be appropriate, because phosphine is a really stinky molecule too. But there's been a lot of controversy about whether that was a valid observation. People said reasons why they thought it wasn't valid, and then further observations seemed to confirm it, and it's still controversial. I'm not sure. I would say the jury's still out on whether there's phosphine in Venus or not. And if there is, it doesn't mean there's biology, but it means there's some interesting, weird, unexpected chemistry going on, and biology is at least one hypothesis. So we'll see. It's gone back and forth, and I think it is one of the things that we probably can have something to say about when DAVINCI gets there with its entry probe, if it hasn't been fully resolved before then. So I'm not hanging my hat on the phosphine being real, though I would say that it's not accurate to say it's been completely disproved. It's more accurate to say it's up in the air. And there is some strange chemistry going on in the clouds and in the atmosphere. And if it's not life, there's something active going on, and maybe it has to do with volcanoes and ultraviolet sunlight, but there's a lot of mystery there. And I personally don't completely rule out some weird microbes in the clouds of Venus. And I think it's just, to me, it's one more enticing reason why we have to explore much more thoroughly this neighboring planet of ours.
Yeah, I hope we learn more about that. That's very cool. Before the show started, Barbara Harris, another one of our panelists, was talking a little bit. Barbara, did you want to ask that question live, or I can summarize it for you if you want to come off mute?
Sure. Frank and I were talking, and I was wondering if is your father Lester?
Yeah, that's my dad.
And I found out about him when I was reading Carl Sagan's biographies, and I know him and Carl were good friends, and I was wondering if that relationship influenced your desire to go into planetary science.
Oh yeah, thanks for the question. It's a fun one, and yes, my dad Lester, who died 3 years ago, actually this month, and Carl Sagan were very best friends for decades, actually. And when I grew up, he was Uncle Carl, and he was around a lot. And this was before he was famous, He was a Harvard professor, I'd say a young, sort of very kind of already prominent young astronomy professor, but he wasn't on television or anything, not that level famous, which he got later. But it was a very riveting presence. He was just as he was on television and in his books. In person, he was very eager to talk about cool things having to do with space, and very sort of mesmerizing to listen to. And so it was definitely an influence. And I had the good fortune later on, after I did end up going into that field, to actually be able to work with him. And I was a summer assistant in his lab a couple times at Cornell when I was an undergraduate, and did some collaborated on some other studies. So it was it was an important relationship for me, from being Uncle Carl from when I was 6 years old to being a colleague when I was had gotten my PhD. So definitely a big influence.
Great. I can't think of a better question to end on. So thanks so much for your time tonight, Dr. Grinspoon. That was an awesome talk, very educational, and I'm excited about 2029 for sure. So
yeah, I please invite me back in 2031 or 2032, and I'll tell you the answers to all the questions I raised tonight if all goes well.
All right, you're on.
All right, thanks.
Thanks so much.
Bye-bye.
Bye. All right, up next we have Barbara Harris with the Variable Star of the Month. Barbara, where are you taking us this month?
Okay, this month we're going to talk about Supernova 2023 IXF. And let's get my slides up.
We got the presenter view there.
Okay, so as most of you know, hopefully already, new supernova is out there, and it's called Supernova 2023 IXF. It's a supernova that was discovered in the M101 Pinwheel Galaxy. It was discovered May 19th of 2023. The discoverer is a Japanese amateur astronomer named Koichi Itagaki. So even though there are these big supernova surveys out there, amateurs can still discover these supernova. This is his discovery image from May 19th. The magnitude at the discovery was 14.9 mag. Now, there are two main types of supernova, supernova type 1 and supernova type 2. And what distinguishes the two is the presence of hydrogen in the spectra. This is an image of several spectra that have been taken of supernova 2023 IXF already. And the green spectra at the bottom is the discovery spectra. So every time a supernova is developed, astronomers want to look at their spectra really quick to determine whether it's a type 1 or type 2 supernova. And the biggest distinguishing factor is that type 1 supernova have no hydrogen in their spectra, and type 2 supernova have hydrogen in their spectra. So I've put up the Balmer series of hydrogen lines, these blue lines here. And this first line over here is hydrogen alpha, that's hydrogen beta, gamma, delta, epsilon. And as you can see, there are emission features that correspond to those these blue hydrogen wavelengths. So this was easily identified as a type 2 supernova because it had hydrogen in its spectra. So there's the big differences between type 1 and type 2 supernova. Type 1 supernova has no hydrogen in its spectra. Type 2 has hydrogen. The progenitor star in a type 1 supernova is usually a white dwarf paired with another type of star. And that other star that it's paired with can either be a main sequence star, a red dwarf, or even another white dwarf. And what happens in this type of supernova is that the white dwarf in the system obtains enough mass where it reaches 1.44 solar masses, and a thermonuclear explosion happens at that particular when it gets to that particular solar mass. it leaves behind as a remnant a neutron star. In a type 2 supernova, like I said, it does have hydrogen in its spectra. The progenitor star in the type 2 supernova is usually a massive star, anywhere between 8 and 50 solar masses. And its remnant is usually a neutron star or a black hole. Type 1 supernova also has 3 subtypes: type 1A, type 1B, and type 1C. And the 3 different types are the absence of hydrogen and the presence of other elements in the spectra, like silicon, helium. And these are the light curves of type 1 and type 2 supernova. They usually have a rapid rise when they're discovered, and then they start to deteriorate in magnitude, and it could be over several days or even over a year. Type 2 supernova, in its light curve, it usually starts to decline, then it plateaus for a while, and then it starts to decline again. So you could also identify supernova by their light curve. But ideally, you want to identify the type early in its history, and not have to wait, almost a year to look at the light curve to identify it. So this is the latest AAVSO light curve of supernova 2023 IXF in several filter bands. It was discovered here at 14.9 magnitude, and it peaked at about 11th magnitude on around the 23rd of May. And I've been measuring it as much as possible. And my last measurement was last night, and it was about 11.55 magnitude. So that's still relatively bright for a supernova. And even for amateur telescopes, it still can be visualized in amateur telescopes. So one of the things I'd like to stress is that there are a lot of surveys out there, professional surveys looking for supernova, like one called Assassin, the ZWF or ZTF, but there are several surveys out there, and amateurs think that with those big surveys, there's nothing for them to do. And especially around this time of year, with it being galaxy season, don't just take pretty pictures of your galaxies, but look at them, and you can download comparison images of galaxies and compare your image to your old previous galaxy images, or like I said, you could download a particular image of a galaxy and compare them and see if there's anything new in the galaxy. So don't just take pretty pictures, but really explore them and see if there's anything new out there.
Excellent, thank you. We do have a question from John Pinto for you. John asks, which are the supernova types that showed evidence of dark energy?
That I'm not sure of.
Yeah, I didn't know that was a thing either.
Yeah, I'm not sure of.
Well, maybe we can ask next month's guest. Next month in our July virtual meeting, we have Dr. Katie Mack, who's going to be talking to us about dark matter. Well, matter, not energy, but
yeah,
maybe
so
we'll
we
go
can
there
put
too.
that question on the back burner until next month.
Luke Corwin says that was type 1A. Okay.
No, the supernova out there now in 101 is a type 2 because it has hydrogen in the spectra. Type 1A don't have hydrogen, and they have prominent silicon emission lines.
Okay. And Frank
and type 2 type 1A supernova are very important when they're found because they can actually be used as standard candles. So cosmologically speaking, they're very important supernova.
Okay.
so they can use to find the distance to the galaxies that they're in.
Cool. Yeah, Luke just clarified he was actually answering John Pinto's question there. Type 1A shows dark energy because they have a consistent maximum brightness. So I did not know that. Thank you, Luke. Also, Frank Fortanese, hello, fellow Frank, welcome, asks, how far away is this supernova?
It's actually relatively close because we already knew the distance of M101, and I can't remember offhand, but it's actually relatively close as galaxies go. So I don't remember exactly, but we actually already knew the distance to M101. So
yeah, very cool. Yeah, and as an astrophotographer myself, I'm getting to the point where I have multiple exposures of the same galaxy year after year. So that comparison is always a good thing to do for sure. You never know if you'll discover something.
yeah, well, especially on these cloudy summer nights, you look for something to do. Go back and look at your images.
Yeah, for sure. And that's a great segue to our astrophotography showcase, of which you're actually up first, Barbara. So let's see if I can share that screen without screwing things up. Let's see, share screen, and we'll do that window. All right, hopefully we're seeing.
Okay, that's M101 with the supernova identified right here in one of the spiral arms. This is actually a composite image. When I do photometry, I'm basically doing my astrophotography of this for photometry. And when I'm doing this, I'm doing it in 3 filter bands, blue, red, and V filter, which is equivalent to green filter. So every clear night when I'm imaging this, I'm taking these, I take 5 images in each band, a minute each for photometry. And basically I've just, this pretty picture image is just all of those images I've taken since discovery, since May. I think my first image was May 21st of it. And just put together and combine them, for this image here. So it's basically a pretty picture image and not for photometry, this particular one.
Yeah. M101's kind of difficult to capture. It has all those faint arms and tendrils and
yeah, all the way out here, they're and,
we got a message here from Robert Vogel, who clarified M101 is 25 million light years away, to be precise. So thank you, Robert. Great.
Yeah,
right,
and that's relatively close.
Yeah. So thank you, Barbara. Great as always. And I'm actually amazed at how many submissions we got this month for the astrophotography showcase. During the summer, usually it's tough to get stuff with all the clouds and lousy weather and the sun going down late, but you guys are a bunch of troopers. We got some good stuff here. So as always, I will hand over the virtual mic for your image if you're online and I see you and I actually hit the right button. Up first, we have Bill Castro. So let me see if I can hand over the mic to you. All right, I think you have permission to talk, Bill.
Yeah, hopefully you can hear me.
Yes, you're good. Go ahead.
Yeah, this is a sketch I made of a multiple star new Scorpii. It's a tough one to split, and it's a personal victory to me. One good thing about double stars is you can see them in light polluted backyards or when the moon is up. I observed this on June 8th with my 92 millimeter refractor, and there are 4 stars to see. Some have likened new Scorpii to the double star, double in Lyra. Now the top sketch was made at 61 power. At this low power, it only looks like 2 stars. The AB pair is mag 4 and the CD pair at mag 6.1 are labeled, and each looks slightly oval. And they're separated by 41.3 arc seconds. Now the bottom sketch was made at 239 power, and the AB pair are barely split by a hair at 1.3 arc seconds. And the CD pair were easily split at 2.4 arc seconds of separation. And there are more details listed here, but for those new to astronomy, the graphic on the right explains separation and position angle for double stars. And note that the position angle starts at north and travels towards the east. So for a Newtonian, east is counterclockwise, like shown in the graphic there on the right, from north. And for a refractor with a diagonal or a Schmidt-Cassegrain with a diagonal, east would be clockwise from north, like shown in my sketches. Now, this double was from a list compiled by Philip Kane, and he compiled 35 stars in this list that were common to several other popular double star lists. So it's kind of the best of the best on that list. You can get that information on that reference on the bottom. Okay, the next one I've got here is the coat hanger, and that's a cluster or asterism, actually. It's a great binocular, finder scope, or wide field telescope object. It's easy even in light polluted skies. And this was featured in the July issue of Sky and Telescope magazine. Now, the above sketch was with my 130 millimeter refractor at 29x and a 2.8 degree field of view. And that compares nicely to the cell phone image I took through the same eyepiece. The cell phone's in the upper middle. The reference article also noted several multiple stars and other objects in and around the coat hanger. So one of these mentioned was multiple star Struve 2521, and I sketched that in the lower left, and that was at 284 power. It looked really, really good. Everything was nice distribution, and the components are labeled there, and you can see their magnitudes and separations on the graph on the right. And to quote the article, so they got a chuckle at the irony of using 200 power when observing the sprawling coat hanger. Now, I've been observing for over 20, almost 30 years, and it's always 8 power, a finder scope or binoculars. I'm looking at the thing, and to look at it at 200 plus power was pretty neat. And I'm finding more and more interest in these clusters you can see from your backyard in light polluted Oviedo. And then noting that there's a lot of double stars in there, you can dive within them and see a lot of good stuff.
Amazing work as always, Bill. Thank you. And for those who didn't hear, you can see an article from Bill in this month's Reflector magazine, right? So,
Frank, can I say something while we're on Bill's image?
Absolutely.
His double, pointing out his double star. I'd like to plug the Astronomical League observing programs, and double star observing is one of them. And I challenge everyone to take a look at the Astronomical League observing programs. And there's a variety of programs, and it's kind of fun because it gives you some direction and purpose to your observing. Like right now, I'm working on the stellar evolution program. So I recommend going to the Astronomical League website and looking at some of their observing programs. A lot of them are fun, and it can be anything from the moon, constellations, or something really detailed like my program, Stellar Evolution.
Very good.
Yeah, I'd like to add to that. For the new members in the club, and if you're in a light polluted backyard, the Astronomical League has the urban program, and those objects are easily seen in the backyard with a modest telescope. So if you're wondering what to look at, that's a great list of objects to start with.
And as a reminder, everyone in CFAS is also a member of the Astronomical Society. And if you want to be more involved in the Astronomical League, we're actually in need of an Astronomical League coordinator for the club. So if anyone wants to step up for that, please contact one of the board members at large, John Pinto or Mark Pernell. You can find their contact information on cfas.org, or just tell me whatever works for you. Isabel asks, I am new to the Central Florida Astronomical Society. What is Barbara's bio? Her talk was really interesting. Barbara, say a little bit about yourself.
Okay, I'm actually a retired physician. I'm a retired OBGYN. I've been interested in astronomy since high school, but didn't get seriously into astronomy until I finished my residency. I looked for property in the late early 90s so that I could build an observatory. I live out between Deltona and Daytona Beach on 200 acres, and I have an observatory. Most of my astronomy is scientific, where I do photometry of variable stars and exoplanets.
And you have a bit of a history with AVSO, do you not?
Yes, I'm probably a 25-year member of AAVSO, and I have about 88,000 observations submitted to AAVSO.
Just a few. And yes, Isabel, that is amazing. Thank you so much. All right, moving on. Oh, this one's mine. So yeah, this is one I took a couple of months ago. This is just a piece of Virgo. And if you don't know, there's a big old galaxy cluster in Virgo called the Virgo Galaxy Cluster. So this is a part of it that isn't imaged all that often. That spiral down in the bottom right there is called NGC 5364. It doesn't have a catchy name or anything like that. And all those other galaxies you see that are, elliptical or edge-on spirals also just have various NGC numbers. If you do want to see an annotated version of this image with the actual designations, you can see it at my website at boldly-going.com. But I just love these images that are just chock full of galaxies. Even beyond those foreground galaxies, there are further ones away there. And if you look closely, a lot of those stars aren't stars. They're actually more galaxies. So it really just drives home how big and vast the universe is and how many worlds are out there. Every one of those galaxies has hundreds of billions of stars, probably hundreds of billions of worlds, and there's countless galaxies out there as well. So it gives you a different perspective on things, does it not? And technical stuff. This was shot from my backyard observatory using a Skywatcher 190 Mac Newtonian telescope with a ZWO ASI 2600 Pro camera and a Paramount Mighty mount. And on a similar theme, we have Wes Clem with a galaxy shot of his own. Wes, let me see if I can give you the mic here. There you go. What are we looking at?
Hello there.
Hey.
All right, so this is sort of the same thing. This is right next door to Markarian's chain. If you look one frame up from that, you get this little group here. Starting in the lower right, we have M88, and then on the left, M89, and then the upper left, M90, and on the right there, M91. It's a group of just a bunch of Messier objects, and I thought, well, once I finished my Markarian chain one, I just moved up here and did the same thing up here, and I really liked these galaxies. I can't wait to revisit a couple of these once I can go deeper. I get my my Edge 8 working. So M88 is that spiral in the lower right, and I just love that little spiral galaxy. I think it's one of the more beautiful ones that I've ever put together.
Absolutely. Love the color on that.
And
too.
what equipment did you use for this?
It is the scope was a Skywatcher SB&F with a ASI 294 monochrome camera on a Skywatcher EQ6R Pro mount.
Yep.
And this is in LRGB, about a little less than 15 hours of integration done.
Cool.
Oh.
Nice tight stars there without any halos. So, for those of you that are interested in astrophotography, we do have a subgroup on groups.io for astrophotography where we talk about stuff like that. So we learn a lot.
Thank you,
from each
Blur
other.
Exterminator.
Yep. Yes, and how to use Blur Exterminator. And this is friggin' gorgeous jellyfish. Tell us about what we're seeing here.
Yeah, here's the Jellyfish Nebula. It's a supernova remnant, like we were talking about. So maybe that one in M101 to look like something like this one day. Who knows? But this also, this was one of the last ones that I was able to get before the clouds rolled in. The star down there in the bottom is Propus, and this is in SHO, so sulfur, hydrogen, and oxygen. And I just loved the way that the spindly bits of the supernova, the remnant there, were able to get defined. And this is on a 400 millimeter scope, so I was really happy with. I guess I had really good seeing during this one because the fine filaments actually turned out really well. So I was really happy with it.
Yeah, awesome.
A gorgeous image. Yeah.
If I remember right, is Cygnus X1 in this area too?
Cygnus X1.
Yeah, there's like a black hole.
Is that the one that's near the tulip in the?
Yeah, you're right. It's the tulip. I keep mixing them up. Also a good target. All right, thanks, Wes. Great stuff.
Thank you.
And up next we have Adam Parsons. Let me see if I can find you in the keynote gallery here. Yes, there you go. What are we looking at, Adam? If you're there, there should be a button to unmute. Oh, your hand's up. Something is wrong. I'm going to forcibly unmute you. No, I can't do that. All right, well, I'm guessing you're having some sort of microphone trouble, so I'll just go ahead and read what you submitted, and go ahead and chime in if you do get that microphone working. But basically, Adam sent in links for 3 different photos, and first we're looking at the M101 image, so we'll start with that. He says he has a lot to learn still, but hey, this is good stuff. All we're done with an Explorer Scientific 208 Newtonian with a Starzone and Nexus 0.75x reducer at f3 and a Player One Uranus C camera on an EQ6R mount. I gotta check out those Player One cameras.
Yeah, cool, and you can see the supernova in the 12 o'clock spiral arm here.
Yep, I see that too, right up there in the top. The orientation's a little bit different from yours, but
yeah,
around 11 o'clock or so. That big bright star, you got the supernova. Oh, you're using a 3D printed guide scope. That's pretty cool. With a cheap Chinese lens and a sensor in it. Very cool. Oh, Adam just put in the Q&A here. Doesn't look like you can type in chat. You don't have a mic on this computer. Okay, yeah, I'll just read it for you, Adam. No worries. All right, so M101 from a few weeks ago, very much a learning process on the imaging and processing, but he's happy with the results. 10 300-second images, and there are Astrobin links here if you want to go hunt those down as well. Also, we've got the North American galaxy. That's his first nebula. These are 20 60-second images stacked up with an L extreme filter. And gotta love nebulas there. That's again, just mind-blowing stuff, seeing these giant clouds of gas where, you know, stars are being born. And it's always exciting to see that for the first time. And your first time seeing and imaging Saturn, that's always a one to remember, right? Some lucky imaging from some random video that he took while exhausted at 5 a.m. I think we've all been there. Absolutely, great stuff. And Saturn is reaching opposition in a month or two, I think, right? So it's getting to be Saturn season. So if you're going to be out there and Saturn's up, it's still rising around midnight, I think, right now. But as the days go on, it will be rising earlier and earlier in the evening. So by the time we get into the late summer, early fall, this should be a really good target. Up next, we have Bob Santin.
Wow.
Santillana. Wow, that's gorgeous. Let's unmute you.
Hello.
Hey, we hear you. What do we got?
Well, I was lucky enough to attend the Nightscaper conference in Kanab, Utah last month. And it was a great gathering of about 250 people from all over the world talking about taking photographs at night. So this is one of my efforts. It's at a place called the Toadstools, which is just outside of Kanab, about an hour and a half, about a mile and a half walk along the trail. It's a blend. The Milky Way is made of 10 shots that are stacked in sequitur and was shot on a Canon 5D Mark IV, ISO 1250 and about a 16-second exposure. The foreground, I did not move my tripod, but I did expose that for about 8 minutes again at 1250 for the ISO, and blended the two together, and that's what I got to come out with.
Amazing composition, beautiful stuff.
Yeah,
What
it's
kind of
really
planning
pretty.
goes into an image like that?
Well, I use Planet Pro to go through and get an idea of where the Milky Way is coming up and what to do. And basically, I've been shooting the Milky Way for about 2 years. I do single shots. A lot of times I'm just starting to get into blending. And I was out there with a group of people who I study with, and we just had a wonderful time. So we always try to scout beforehand, just to be on the safe side, because the walk out there was very interesting. At one point, we had some drop-offs that were probably 75 feet on each side, and you're walking on along about 2.5 foot path. So it was interesting, but it's a lot of fun. And you try to go without a lot of light, so you don't screw up anybody else's pictures.
Mm-hmm.
No, I know I'm not supposed to say this as an astronomer, but I love the little clouds down there in the image.
Well, we were waiting for the clouds to get out of the way. One interesting thing about being in Kanab during the conference was there was a planned power outage over 2 counties while they upgraded their electrical system. So we were actually able to walk in the middle of Kanab and take Milky Way photos, because it happened to be a clear night, right in the middle of town. And it was pretty spectacular. I'm still working on those images.
Gorgeous stuff. And I love how we've seen like a wide range of astrophotography already tonight. You know, we've seen deep sky, we've seen nightscapes, we've seen planetary. So there's a whole range of techniques and stuff you can do with a camera at night. So we're just seeing some of it now. Thank you, Bob. Great stuff. Up next, we have John Starr. Let me push the button on you. And wow, tell us how you did this one.
Yeah. Hey, good evening. So this was taken early Monday morning. The SpaceX had a launch from Pad 40, another Starlink mission at 3:10 a.m. So I woke up early around 1 o'clock and made the drive over. A fair amount of planning went into this shot. And I used sort of Flight Club and Stellarium and Google Maps, and then I checked and rechecked, and I had been planning this shot for I guess a week or so, and the actual, it got delayed. The mission here got delayed a couple times, and so then I had to recalculate and figure out where I was going to move to and everything. And so ultimately ended up at Rotary Riverfront Park in Titusville, and sort of hiked down to the water and kind of actually hiked off to the side of the park. And I wasn't the only photographer there, since there was really only one place you could be to get a shot like this. A couple other folks had figured that out, and so got to talk to them. That was kind of fun. But I shot this with a Canon EOS R, using a Sigma 150 to 600 at 600 and at f6.3 ISO 1000 and 1/1000th of an exposure. And so I took a whole bunch of shots, and I sort of chose the one. I took 54 shots in total, and sort of chose. This is a single frame, so this isn't a composite or anything. And this is the one I sort of chose where it's kind of lined up that it looked nice.
Awesome. I love the black cloud coming
Me
off
too.
the plume there. Yeah. Usually it doesn't look that way. So it's like a dark nebula or something. Very cool. Amazing stuff, John. Thank you. Up next, we have Len Ward, and I don't see you in the attendees here. If you are lurking somewhere, Len, raise your hand, put something in the Q&A, jump up and down virtually and let me know, but I'll just read what you submitted here. Leonard Ward says, trying to put Richard's old 20mm lens, which is his now, to work. Everything came together for a shot of Venus and Mars converging on the Beehive in the Crab constellation. For tech information, he's got a Canon T1i 550D with a Sigma 20mm f1.4 art lens mounted on a tripod, ISO 800, f1.4, 1.6 seconds, processed with PixInsight to bump up the stars and not Venus. Shot from his backyard. So thank you, Len. And finally, we've got a couple sent in from Richard Wright. I don't think he's online because he is out at the Grand Canyon taking advantage of the clear, dark skies out there. So here's some of his transmissions from the Grand Canyon star party that's going on. From what I hear, he's one of the few people that are actually staying up past midnight to get shots like this. So kind of surprising the astronomers are going to bed early out there. Anyway, he says both are single exposures, both with a Canon EOS RA and a Tamron 35mm f1.4 lens, which is the best Milky Way lens he's ever tried or owned. And Richard Wright would know because he's tried a lot of them. So I'm going to make a note of that. Tamron 35mm f1.4. The Milky Way image that we're looking at right now is 30 seconds at ISO 1600 and f1.8. He used a Skywatcher Star Adventurer GTI to track for the 30-second exposure. He did nothing fancy with this image other than a little curves to bring down the background some and to dehaze it. Slight saturation tweak too, just like you would for a parrot at the zoo. I didn't know that either. I'm not much of a photographer. It's amazing how well a single well-exposed image under pristine and transparent skies at 7,000 feet can require so little effort. The bright nebula along the center line of the galaxy are all just popping out too, thanks to the RA's greater HA sensitivity. The full resolution image is just amazing to explore at 200%. The green at the bottom of the image is from air glow, glowing oxygen, which shows up easily on most cameras, but only at very dark sites. And the second image is a nightscape from the Desert Watchtower. Now I got All Along the Watchtower by Jimi Hendrix stuck in my head, which is an often missed feature of the Grand Canyon National Park. Well, it depends which way you go in, Richard. You know, if you go in from the side, from the Indian reservation there, that's the first thing you see. But anyway, he was the only freaking person there in the dark. This was 5 seconds at f1.8, IS 3200. The sky is a bit blue. It was not quite twilight yet, so he did not correct it out. Wow.
Pretty.
Yeah. Oh, Isabel wants to know, can we write the latest picture of the Milky Way Grand Canyon equipment list in the chat? Yeah, let me paste that in there for you. I think I can do chat to everyone. That's the camera and the lens and the mount, the little portable mount that he used. Keep in mind, Richard is on the road, so he can't really bring a big, heavy mount with him. He's got one of those portable sky trackers that you can put in your luggage.
And so. I just purchased that about 4 or 5 months ago, and it is a great tracker. And what distinguishes it from the other trackers is that it's a little go-to mount also. So you don't have to spend a lot of time trying to find your target. It's actually a little go-to mount, and it has a 11-pound capacity. It's a great little mount. A Skywatcher Star Adventurer GTI.
Well, I'm going to write to Santa for that one for sure. Very cool. And I think that's all we have for astrophotography this month. Again, we're going to have another virtual meeting next month, so keep those pictures coming. We'll ask for that in about 3 weeks or so again. Coming up next month, again, our main speaker is going to be Dr. Katie Mack, a well-known astrophysicist and author. She's going to be talking to us about dark matter. And believe me, she's qualified to talk about it. So if you always wondered about the mysteries of dark matter, tune in next month and we'll learn all about it. We're going to be taking the month of August off as we normally do because, well, you know, there's not much going on in astronomy in August. It's cloudy, you know, sun goes down late. Kids are out of school. There's not a lot of outreach going on either. So we're going to take a month off and take it easy. September, we'll be back for our grand reunion at the planetarium for our next in-person meeting. So stay tuned for the details of that as we get closer to it. And looking even further ahead in October, we'll be doing our annual meeting with election of our new officers and our new board. If you are interested in serving on the board, please again let our board members at large know, either Mark Pernall or John Pinto. They're going to be putting together the election slate. And we do anticipate having a couple of openings on the board. So if you want to get more involved, this is your chance. And you know, be more involved behind the scenes and making CFAS awesome. And with that, that's all I have for this month. Tricia, if you're still there, do you want to close things out?
I am here. Can you hear me?
Yes.
Well, thank you guys. Thank you for coming out. It was an excellent meeting, and look forward to seeing whoever signed up for Derek's astronomy class. and also Astronomy on Tap next week.
Absolutely. Yep, some good stuff coming up. And there's also an outreach event scheduled for August, if I remember right, but more details on that to come as well. All right, well, on behalf of our president, Tricia, and for the Central Florida Astronomical Society, I'm your vice president, Frank Kane. And as always, keep looking up. I'll see you next month. Thanks, everyone.
Good night, everybody.
Bye, guys.